Okay, integrating this one here hopefully isn't going to be too bad. We'll just split it up. So cos x dx plus x squared over x is an x, and 1 over x dx. Sine goes to cos, so it's just going to go straight back to sine. Add 1, divide by it. Derivative is on the top, modulus, plus c. So that hopefully wasn't too bad. Same year, the C4 paper now. Question 1. Unfortunately, it's telling us we have to use substitution. So let's just go about the business. Differentiate, rearrange to get dx equals. So it's dx. So just rewriting your integral. 3x, add, that should be at 2. u5 dx is now du over 3. So how do you integrate? You add 1 and you divide by it. So it's a 3 and a 6 in the bottom. Don't forget your c. And just putting your u back in to finish it off. Okay, so question 8 now. A wee bit of a longer one. Partial fractions. Before you do partial fractions, remember you have to factorise, and that's the difference of two squares. So it goes a over 2 minus x plus b over 2 add x. And doing at the top, x add 3 equals a. This one needs a 2 plus x, and the b needs a 2 minus x. Choosing x3 minus 2. Minus 2 add 3 is 1. That one disappears. 2 minus minus 2 is a plus 2, which gives you 4. So b is a quarter. And then choosing x to be 2, to get rid of the far bracket here. So you have 5 equals 4a, so a equals 4 over 5. So your expression up here can be written as a, 4/5 2 minus x, plus b, 1/4 2 add x. Part 2, exactly the same expression, so just pop in this answer here. I'm just going to split the integral up as I go through it. So 4/5 1 over 2 minus x dx plus 1/4 1 over 2 add x dx. Before you can integrate, you must check you've got the derivative on top. The derivative is a minus, so balance it outside. So minus 4/5 log the bottom line. Derivative is on top, so just log the bottom line, and don't forget your c. Now, volume. Volume is going between 0 and pi over 6 of y squared. That's quite an interesting wee one. So I've got a bit of pi in there. So squaring your y, you get sec squared tan squared. Now, in my head I'm thinking, if you differentiate tan, it goes to sec squared. So I'm seeing that as a bracket, because if I treat that as a bracket, the derivative is in front. Well, near enough the derivative is in front. I've got to just put the 2 and then balance outside by half. So if you differentiate this bracket, you would get 2 sec squared, 2x, which is what I've got. So I can now integrate the bracket. So you add 1 to the power, so it's 3, and divide by it. And you've got limits, pi over 6 and 0. So just plugging those in. So pi over 6, and you've got tan 2 pi over 6 is pi over 3 cubed. Let's double check what that is. So tan pi divided by 3 is root 3. Sorry, you put in tan 0, it's 0. So it's pi over 3, and it's root 3 cubed over 3. And that, if I just put this into the calculator to double check my work. Now I just want to double check this a wee second. So pi over 2, so add 1 to the power 3, divide by it. So that's all looking fine. So it's tan pi divided by 3 is root 3, and then you cube that,